Hey everyone, welcome to The Explainer. Today, we're diving into what I like to call a highly rigorous scientific study from back in 1957. Well, okay, that's exactly how our subjects prefer to remember it. Anyway, we're going to travel back in time to the rural farming community of Chumuckla, Florida, to examine a really nostalgic childhood memory. But we're going to look at it entirely through the lens of pure, unadulterated physics. So, here's the big question I really want you to keep in mind as we go through today's analysis. How did two incredibly stubborn kids in 1957 Florida inadvertently master the laws of thermodynamics? Seriously, it's this hilarious, true story of freezing cold mornings, a whole lot of stubborn pride, and ultimately, sheer survival.
Okay, let's dive into this. Our subjects for today's experiment are Vic and Jim Campbell. Now, they were just second and third graders at the time, and their initial hypothesis? It was simple. They just didn't need winter gear. As Vic himself actually wrote in his local newspaper column years later, we preferred not to wear a coat because it would constitute an admission of frailty, right? So they were completely convinced that second and third graders were just way too tough to ever admit they were cold.
But, as you can probably guess, this is exactly where their stubborn no-coat rule met some pretty harsh reality. On one hand, we've got the catalyst, this frigid, literally toe-freezing, liver-congealing air slipping unannounced south right out of Alabama. And on the other hand, we have the variable they absolutely couldn't control, the weight. See, the boys had to stand outside on this rural highway for up to 30 minutes, just waiting for old man Claude Jernigan to finally show up in Bus 53, grinding its gears and belching blue smoke. So yeah, something had to give.
Which brings us to phase 1 of the experiment, discovering radiant heat.
Basic survival instincts really started kicking in out there on that rural blacktop. The boys turned to science. I mean, even if they didn't quite know the fancy academic terms for it just yet. So let's formally define our first variable here, radiant heat. Basically, this is the transfer of heat energy through electromagnetic waves, just like the sun warming a surface. The boys figured out pretty quickly that the bright Florida sun had been beating down on that blacktop highway all day long. Which brings us to the actual physics formula for Prevost's law. I mean, wow, it looks incredibly intimidating, doesn't it? Q over lambda dA times T4 minus TB4. That is some absolute high-level thermodynamics right there. Now, what's really interesting about this is how we take that super dry textbook math and translate it into the Chumuckla application. All that incredibly complex physics, it really just explains why that Florida highway held onto the sun's heat all night long. The road just felt wonderfully, amazingly warm against that biting morning chill. Moving right along to phase 2, convection and conduction. So as the morning temperature kept dropping, radiant heat alone just wasn't quite enough to thaw their freezing ears, right? So they had to escalate their methodology. First up, they discovered convection heating. This is the transfer of heat through the air, which actually allows you to feel warmth without even touching the source. The warm blacktop was releasing all that stored heat straight into the freezing morning air, creating this super helpful, cozy little pocket of warm air just above street level. You could actually feel a real difference just standing right next to the asphalt. But to truly survive that Alabama permafrost, they needed to tap into conductive heat. That's the direct transfer of heat between two objects in physical contact. So ask yourself, what is the ultimate extreme escalation of a cold weather survival strategy for two freezing little boys who refuse to wear coats? Well, let's briefly consult the math again just to keep our rigorous scientific framing intact. Here's your standard formula for conduction. Q equals Ka times T2 minus T1 over D times lambda. And honestly, this just brilliantly illustrates the absolute hilarious contrast between a dry classroom and the real world. The strict physics definition calls it direct molecular heat transfer. But the Chumuckla application? That involves two young boys literally lying flat on their backs, right smack in the middle of the highway tar. Okay, let's walk through the exact methodology of this highly sensible maneuver. Step 1, lie down flat on the highway. Step 2, absorb heat directly from the tar into your frozen body. Step 3, whenever a car approaches, jump up and rush off the road as fast as possible. And step 4, cool down and repeat the whole shebang. As Vic Campbell noted in his later writings, not only did this practical trick keep them alive, but dodging all that oncoming traffic provided a truly fantastic bonus of reflex development. And that leads us into phase 3, the Whitley variable. Now, as we know, in any good scientific experiment, you always have to account for outside disruptions. I want you to put yourself in this scenario for a second. You're driving down a quiet rural road on a freezing cold morning. What exactly happens when a local educator witnesses this bizarre experiment in action? Well, here is the chaotic turning point of our morning. The observation. Vic's second-grade teacher, Mrs. Whitley, approaches in her car. The reaction. She slams on the brakes, skids to a complete halt, and her eyes go completely wide with sheer excitement, or let's be real, probably sheer panic at almost running over her own students who are literally lying down in the middle of the street. The results. She immediately reports these brilliant scientific findings straight to the boys' parents, and just like that, the Great Highway Experiment comes to a screeching halt. Which actually brings us to this wonderful piece of documentation. This is Vic Campbell's original newspaper column recounting the whole crazy event, aptly titled, "Campbell Recalls Practical Physics. It Wasn't Gravity That Got Us." I love this because it anchors this completely unbelievable, chaotic morning story right into documented local history. Finally, we arrive at Phase 4, Thermodynamics of Applied Friction. This phase covers the final consequences of their actions, which were delivered strictly and very effectively by Mama Campbell. Let's define our final scientific term for the day: applied friction. In this very specific 1950s context, applied friction was actually a mama's swift, targeted physical discipline applied directly to the backside. Yep, a good old-fashioned spanking to really drive that safety lesson home. So let's review the final data set, shall we? Mama's physics lesson definitely left a very significant impression on their minds. The boys' immense stubbornness regarding winter clothing, entirely eliminated, and, most importantly for their health, winter coats were actively worn in absolutely all subsequent cold weather. I'd say the behavior modification portion of the experiment was a resounding, absolute success. It really just goes to show how much science is hidden away in our daily lives. And sometimes it's those hardest lessons that end up sticking the longest. So it makes you wonder, what unexpected childhood misadventure has provided you with your most lasting educational lessons? Take a moment and think about the practical physics you've survived in your own life. Thanks so much for joining me on this explainer, and I will see you on the next one.